So if you're watching this, I hope that you have all of your gas law conversions available, a calculator and a piece of paper, because this video is really designed for you to practice with the math part of gases. And so our first problem here is a gas stoichiometry. It's asking for the volume of HCl that we can make. And so we have that handy conversion that 1 mole of a gas is 22.4 liters. And so we are going to use that here, but we don't know how much HCl we're making. We do know that we're starting with 10.2 grams of NaCl. And so I'm going to have to use my stoichiometry and go from grams of NaCl to moles of NaCl, then from moles of NaCl to moles of HCl. And then 22.4 liters equaling 1 mole can take me to my volume or my liters of HCl. So again, always start with what's given. You can put that over 1 if you like. And then, of course, molar mass to convert grams of NaCl to moles of NaCl. Notice that my grams of NaCl are going to cancel out here, and I've got moles of NaCl. But I want to find HCl. So how do I do that? Hopefully you're thinking the balanced equation. Yes, because we've got a 2 to 2 mole ratio. Notice that my moles of NaCl cancel out. So now finally I've got moles of HCl. And that's where I said I was going to use that handy dandy conversion. 22.4 liters is a mole. And I didn't even put HCl because it's for any gas. And then straight across the top, multiply 10.2 times 2. Times 22.4 divided by 58.5 times 2, and you should get 3.91 liters of HCl. That's got 3 significant figures. That's what came up right up on my calculator, and 3 significant figures are given in the measurement of my problem, so I am good. So there's our final answer. Let's take a look at some more. So these are just random gas law problems. And so as you're taking a look at this, the first thing I would do if I were you is look at what I've got. Okay, 250 milliliters, that's a volume. 25 degrees Celsius, that's a temperature. Then we've got 95 degrees Celsius, another temperature. It's asking for a volume, so I got 2 temperatures and a volume. Yep, hopefully you were thinking Charles's Law. Charlie Brown is a TV show. Now, I could have put down the combined gas law, which would simply include the pressures. In this case, though, I don't have any pressure information to put in, so I could just knock that pressure out. And then I'm going to do some conversions. I'm going to convert my volume to liters, my temperatures to kelvins, and substitute them in. And there they are. So how do you solve for V2? Well, you can kind of do it however you like. I'm likely to take 0.250 divided by 298 and then multiply by 368 to get V2. And that's exactly what I've done. Then I'm going to multiply both sides by 368. And I come up with 0.3087 for my volume. Now let me take a look back at my significant figures. Okay, 2 in my problem, so I need to round 2 to my answer, and so hopefully, come on. For my final answer, I've got it down to 2 significant figures. All right, here's your second gas law problem. So it's asking how many moles. Well, I know something about moles and liters. I know that, and I've got liters. I know that at STP, 22.4 liters of a gas is a mole. Well, it gave me liters, and it's asking for moles, so I can simply use my dimensional analysis skills to do that. Notice that my liters here are going to cancel out, and I'm left with moles. And now I've just got to round to significant figures. So I put it in scientific notation to get it to 3 significant figures. All right, here's the next one. What are you going to do first? Hopefully you're thinking, okay, let me look at what I've got. I've got 3.8 liters. That's a volume. I've got 45 degrees Celsius. That's a temperature. 5 degrees Celsius. That's a temperature. So volume and temperature. Temperature and volume. TV. Charles's Law. Charlie Brown is a TV show. My volume is already in liters. So what am I going to do with my temperatures? Hopefully you're thinking convert those to kelvins. You're exactly right. That is what you're going to do. And then you're going to hopefully substitute those in and solve for V2. The way, and so hopefully you got 3.3. My only problem with that one is, though, I've got one significant figure, so I'm actually going to have to round that to 3 liters. Because here I've only got one significant figure, which is why as you're doing the labs, it's so important that you measure as precisely as possible and get as many significant figures in your measurements as you can. Because obviously our answer is not as good as it could be. All right, here we go. Next one. What are you going to do first? Yep, hopefully you're looking for what's given. Okay, I've got a volume, a pressure, and another volume. So whose law is that going to be? It's asking for pressure, pressure and volume, PV. Boys play video games, Boyle's Law. Once again, you could throw a temperature underneath of each of those if you wanted. For our combined gas law, but because you don't have any temperature information, you wouldn't have anything to put down there. So what do I need to do with my pressure? Take a look at that pressure. Hopefully you're thinking convert that to atmospheres. That's typically what I would do. Oh, in this case, sorry, I left it as kilopascals, and that's fine. Except for this should be P2. Because I've got my volumes and I've got my pressure left in kilopascals. And so as I solve this one, and I can leave it at 3 significant figures, my pressure is still in kilopascals. So if I change it to atmospheres, then it would be in atmospheres. All right, here's your next one. Oh. Obviously, the animation's not working on this one. So it's asking about total pressure. So when we're asking about total pressure, whose law are you thinking about? Hopefully you're thinking Dalton's law of partial pressure. And so I've got a pressure here in kilopascals. I've got a pressure here in atmospheres and another one in millimeters. So I need to get them all to the same thing. My preferred pressure when I'm dealing with gases is atmospheres, because if I was using the ideal gas law, it has to be an atmosphere. So I'm going to convert everything to atmospheres. So of course, 342 kilopascals is going to equal 3.38 atmospheres. 52 millimeters of mercury from the helium is going to equal 0.068 atmospheres. So now that I've got those converted over, I'm going to use Dalton's law of partial pressure. I do have 3 different pressures, and I'm simply going to substitute those in, add those together to get the total pressure. All right, here we go. See if you can do this one on your own. This would be a great time to pause the video and see what you can do. So hopefully you're back and you've got an answer. Hopefully you decided to use PV equals nRT. because we have a temperature, we have a pressure, we just need to convert that to atmospheres, and we've got a volume. And it is asking for our number of moles, or in this case, N. So that's how I knew to use PV equals nRT. So all right, and so I skipped one back there. There was some problem with that one, and I'm almost finished with this video. Here's a great gas law and stoichiometry problem combined together. We're burning a candle, a paraffin candle. We know the temperature of the flame, and we're trying to figure out what volume of CO2 is produced from this chemical reaction, and we do know our pressure. So let's take a look at what we've got. We've got a temperature. Of course, we're going to need to convert that to kelvins, right? Not going to worry about significant figures yet till the end. We've got a pressure, but we've got to convert that to atmospheres. We've got a mass. But our mass, of course, needs to be converted to moles. And for this one, we're interested in the CO2 gas, not the mass of the paraffin candle, C20H42. So we're going to have to figure out the moles of CO2. And since I've got a pressure, a volume, or a pressure, a temperature, and a mass, I'm going to use PV equals nRT. But first, I'm going to have to figure out the moles of CO2. I know my candle's 125 grams. If I burn the whole thing, I can figure out the moles of CO2 by figuring out the moles of C20H42, that's paraffin. And I've got a 40 to 2 ratio of CO2 to paraffin. So that gives me 8.85 moles of CO2. And you can see my CO2 is getting a little bit cut off there. And so simply substitute in each of the values and then solve for V. So if you multiplied the number of moles times our temperature and then divide by the pressure, you should find out the volume, which is what it's asking for. And there, it's cut off just a little bit. Let me see if I can get this. So that you can see it. So there you go. A volume of 1168, rounded to two significant figures, 1,200 liters. So one little candle, one little 125 gram candle is going to put out 1,200 liters of CO2. And so what you may want to do is take a look at the rest of this PowerPoint and just, there's like 2 more problems for you to practice with. If you have any questions, just let me know.